that. Let's see who's joined. Okay, Channel is there. Channel and Mangaliso, what are you guys currently busy with? What are you currently busy with in your school? Maybe let's start with Mangaliso. Mangaliso, what is it that you guys are currently busy with in school? I'm not sure if Mangaliso is able to hear me, but it's fine. The other... Yes, now I can hear you.
Sir, I couldn't hear what you said.
Okay, I was just trying to confirm what you guys are currently busy with in school.
Oh, for physics, we just finished with covalent and ionic revision.
Okay, so in short, chemistry. Okay, then it's fine. Let's go to what is it? Chianeo. Chianeo, can you hear me?
Yes, sir.
Yes, what about on your side, honorable member?
We're busy with electric circuit.
Seconds. Okay, then it's fine. Just as okay. I wish you were doing something different because that is the topic that we're going to be doing in today's lesson. The reason why I wish you were doing a different topic is because I prefer for you guys not to study the same thing at the same time. But otherwise, it's fine. At least once we go deeper, you will be in a better position to either be ahead of everyone in class or understand things better. Maybe let me check Ompile. I see Ompile is on the line. Ompile, what about on your side, honorable member?
We are busy with electrostatics.
Okay, that is good. Chianeo responded, Lihumo, what about you, honorable member?
We just finished electric circuit, so now we're doing a revision of all the topics.
Good. Andrew, what about you?
So we're doing electric.
Okay.
Electric.
Okay, then it's fine. I'm just quickly going to share my screen. Then from there, I'm going to take you through the basics of electric circuits, just so that you've got an idea of what this topic is all about. So, in today's lesson, honorable members, in today's lesson, I will be doing more of the talking. Maybe towards the end, I'll give you guys an opportunity to do some work. But in the meantime, I would like to make you guys aware that electric circuits is what I'm going to be looking at. So guys, we've got two types of connections. Remember, in school, they might be teaching you about something completely, not necessarily completely different, but I mean in terms of the approach. The way I'm going to approach this topic is going to be different from how they approached it in class. So what I'm trying to achieve in my lesson, it is just to give you an overview of everything that has to do with this topic, so that even when you do it in class, you expect certain things of which you are aware of. Okay, what I'm now going to talk about, the most important thing is types of connections. Types of connections. And remember, guys, I'm not referring to my notes. I'm just teaching you this out of my understanding of this topic. So the first type of a connection is called series connection. The second type of a connection is called parallel connection. These are the two types of connection that we have. The easy one is series. When it comes to parallel, it is also easy, but not as easy as series. In exam, they like combining these two types of connections, and they ask you questions based on these two types of connections. So these are the components or devices that we use in order to form an electric circuit. We have what we call this thing. You see, when it's a single, those two lines, the longer one and a shorter one, we call this thing a cell. It's like that cell that you put inside, what is it? The remote, TV control remote. So if you have more than one cell, which means it can be two or more, then we no longer call it a cell, but we call it a battery. And how you represent it on that, even though you won't have to draw it, they will just draw it for you. So that means this is a battery because you can see you've got two cells. So that means more than one cell, it's a battery. The long line represents the positive side of the cell, and then that will be the negative, meaning the long line will be the positive side, the shorter line will be the negative side. Why do you have to know this? It's because it is going to help you to know the direction in which the current flows. Current flows from positive to negative. Current flows from positive to negative. You will understand why I'm interested in you understanding that part. We also have this thing called resistor. And this is normally how a resistor would look like on an electric circuit. Sometimes myself, I can just do that, but you will just know that this is a resistor. I'll explain shortly in terms of how you will know. Okay, then something that you need to be aware of is that we've got a meters, just like water meter, which measures how much of water passed through that meter point. In these instances, we have what we call ammeter. Ammeter, which measures the flow of current. And then the last meter that we have is called voltmeter. Voltmeter measuring the potential difference across whatever component. Don't worry that much. You will understand as soon as I draw an electric circuit. Maybe on this page, let me just talk about the formulas that we normally use. So we've got two main types, not necessarily two main types, but is it two? No. For now, let me say we've got this formula, which is the main formula, which says V is equals to IR. It should be easy to remember. If you just remember it like this, to say V is equals to IR, you will never go wrong when you have to use this formula. Okay. We have another formula, honorable member, to calculate R total. This formula for calculating R total, it's only one. So R total means you just add. What are you adding? Resistors. So if you have 3 resistors, you will just say resistor 1 plus resistor 2 plus resistor 3. You get the total resistor. If it's 4 resistors, you just keep on adding. If it's million resistors, you just keep on adding until you have million. That is the formula to calculate R total, being the total resistance. Okay. There is this formula that they call R parallel, which says 1 over, can you see small letter R parallel? They say this formula is equals to 1 over, if you have 2 resistors or 3 resistors, you'll just say 1 over R1 plus 1 over the second resistor plus 1 over the third resistor. Can you see? So these are the formulas that we are going to be using a lot, honorable members. Remember, guys, I did say, please give me the first 30 minutes or so to just do a presentation. And I'll give you guys an opportunity to ask me some questions when necessary, or I will give you some work to do based on what I'm going to firstly explain to you. Okay, so now let me try to draw an electric circuit to give you guys a picture of what's going on. So every time when you see what is it? Your battery, just think of it as a water valve. It could be a water valve or a water pump. I want to draw something. Then you have a hose pipe. I'm sure you guys know what a hose pipe is. A pipe where the water flows through inside. Yes, the water flows inside. Okay, so if this is a cell like that, that means the current of which the current, think of it as the water. So the current flows from the positive side towards the negative side. So the hose pipe, think of it as a wire, which is what they call conducting wire. Think of it as the pipe. So that means the current, it is the water flowing inside the hose pipe, and it will flow from the positive side towards the negative side. So can you see? This is the current flowing through the wire. This is what it does. It will forever flow like that until the battery dies. If it doesn't die, it will just continue flowing unless we have a switch where we can turn the switch on and off. So that means a switch will be something that can be added there. That switch that you toss, and then in your room the light goes on, you toss, it goes off. That is the switch that I'm talking about. So this type of a connection, honorable member, it's what we call a series connection. So for example, you can have your TV connected there. You can have your stove connected there. You can have your phone charger connected there. What else can you have? You can have your fridge connected there. So that means these electrical appliances on an electric circuit, we represent them as resistors. So there is a resistor, there is a resistor, there is a resistor, there is a resistor. So you can see that the current that is flowing, it is passing through the TV. That means the TV is on. You can watch Movang. It is passing through the stove. That means the stove can be turned on. You can cook a putu there. It is passing through your charger. That means your battery will be full and you can be able to attend the lesson. It is passing through the fridge. Then it means, what is it? You can be having your Danons there. And then it goes back to the negative. Then it will continue until, for as long as the switch is closed. When the switch is opened, this is how it is represented. It's like you disconnect it. You see, now the water will not completely flow continuously, but it's more like a leakage. So that means now the circuit is not closed, but it's opened. So let me show you guys something. The resistor for this one, it can be 1 ohm. That's how we represent a resistor. For a stove, it can be 2 ohms. Okay, for the charger, maybe we can say 1. Maybe for fridge, let's say 3 ohms. These are just examples. So a question may come where they say calculate the total resistance of this electric circuit. You just need to know what is the formula to calculate R tot. We just said the formula to calculate R tot is this one, which says you must take R1 plus it with R2 plus it with R3, you plus it with any other resistors which may exist on an electric circuit. So now let's see. We have R1. I usually start from left, that ending on the right. So that means in terms of total R, we have that one of 1 ohm plus that one of 2 ohms plus that one of 1 ohm plus that one of 3 ohms. What will this be? That and that is 3, 4 plus that is 7. So that means R total is 7 ohms. In physical sciences, you get a mark for correct answer, a mark for correct substitution, a mark for correct answer with the correct SI unit. Let's say you had your battery having this one having 1 volt and the other one having 1 volt. So that means each cell has 1 volt. So that means your battery has a voltage of 2 volts. So another question which may come, they can just put a meter there, more like an ammeter, and say, okay, since you are a physicist, tell us or calculate the value of the flow of current. We want to know the value of the flow of current. Okay, we know that the formula says V is equals to IR. It doesn't change that formula. What is your V? Your V, we know it is 2. What is your I? I is what you are looking for. That is the current. What is your R? Okay, your R is 7. So now as a mathematician, you know that to remove that 7, you need to divide both sides by 7. Why? So that that cancels with that. So you end up having your I, which is equals to 2 over 7 amperes, which you need to write in or as a decimal, and that will be 0, something. Very quickly, let me just work it there and say 2 divided by 7, that is 0.29 if you round it to 2 decimal places. That's how you would make a calculation on a series connection. Okay, before I talk much, let me just check if there's anyone who's got a question. Otherwise, if not, I will do something where you guys will need to very quickly do a calculation. Let's check, guys. Andrew, Atli, Lihu, Mangliso, Ompile, and Chanel. Are you guys okay? Did you understand what I've explained? Are they?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, then it's fine. Very quickly, let me give you guys something. Let me give you guys something very quickly. And let's see. Let's say we have this. And then let's say we have that, we have that. So let's say this is 2 ohms. This is 1 ohm, 3 ohm, 1 ohm. And then there, maybe let's say 20 volts. The first question, I want you guys to calculate the following. First question, calculate R. Sometimes they can say R effective or effective resistance. Effective resistance. Or sometimes they can say a resultant resistance. Yeah, resultant resistance. Just know it is the same as R tot. Next thing that I want you to calculate, where can I put my ammeter? I'll put it there, it's fine. And then I will say calculate reading on ammeter. You just need to know that when they say reading on ammeter, they just want you to calculate I, but they won't say calculate I, but they will just say calculate the reading on the ammeter. So very quickly, work it out. As soon as you get an answer, comment in the comment section and let me know what answer you got on that one. Did you guys hear me on that one? Do you guys know what you are supposed to do?
So
Yes, sir.
Yes, sir.
Goodest. Okay. I noticed that I need to be there so that you guys can see. And no. I don't know why. I don't know why. Luckily, this is recording. Let me quickly check. Yes, luckily this is recording. I will try to redraw that, even though I can't remember exactly what the values were. But I just remember that I need to be quick before I forget. I just remember that I had this. My ammeter is fine. I can still put this side. I think here I had 20 volts. I think I had resistor there, another one there. I'm not sure if what did I say these resistors were, honorable members? I think I had 1 ohm there. 1 ohm there. Did I have 2 there? And then 3 here. I think so. And then I said calculate. First question are taught. Second question, I wanted you to calculate reading on ammeter. You see, the reason why I can't remember those values is because these things are just coming out of my head. Guys, did I redraw it correctly? Are
Yes,
these
sir.
the values that I initially had? Okay, then it's fine in that case. It's fine in that case. You can just very quickly work it out and let me know. Work it out and let me know what you guys are getting as your answers. Guys, if you are done, you comment 1, this is the answer, 2, this is the answer, and then just unmute and say I'm done. Something that maybe is worth saying is that V is measured in V. The unit for V is V. If you're calculating R, the unit for R is ohm. If you're calculating A, the reading for A is ampere. So that means you just say not for A, but for the current. So the current, just think of water flowing inside a hose pipe. Makes it very much easier in that way. Because when we get to the parallel connection, you will need this understanding. But let's see, guys, are you still working on it? Are you done? What's happening there? What is the status on your side? Okay. We have 2 comments, someone saying 7 and someone saying that. Okay, 3 comments are enough, but the answers for Mangliso are wrong. Wrong. Answers for Mangliso are wrong. Mangliso, do you know why your answers are wrong?
Is it because I didn't write ohms and like I didn't
Yes,
do
because we don't know if you are 7 years old. You see, Mangliso.
Yes, sir.
Yeah, so it must be clear so that we don't think your birthday is coming very soon. So you have to tell us to say this is 7 for the resistance and it's 7 ohms. This is that for the current. And again, if you are given a math problem and your answer ends up being a decimal, always round it to 2, unless if they say round it to the nearest, round it to 1 decimal place, round it to 3 decimal place. If they don't say, then you always round it to 2. Make sense? Mangliso.
Yes, sir.
Goodest. Other honorable members, what's happening there? Ompile, are you still there or are you watching Skim Sam there? What are you doing there? Ompile, I can't hear you. Mangliso Andrews commented. I'm not sure what's happening there because the honorable member isn't responding. Okay, Andrew, your second answer is wrong. And I'm sure you understand why it is wrong, because it doesn't have the unit. And again, yeah, that's just it. But you just need to know that you need to round it to 2 decimal places. Okay, so now I'm going to teach you about the second type of a connection. Very much important, honorable members. This type of a connection, very much important because it is the type of a connection that makes this topic difficult. So we call this one, or this type of a connection, parallel connection. This is the type of a connection that we are going to be dealing with. Okay. Remember, you will definitely have a cell or a battery when dealing with the electric circuits, but in this one, can you see it splits? It splits like that, and then it continues to join on the other side. Then you have resistor there, which is parallel to that. That is why we call it a parallel connection. I will draw more like a hose pipe, just so that you've got an idea of how it would look like if I had to draw a hose pipe, so that we can visualize if there was water flowing. There. Okay, so let's see. How will the water flow? It'll obviously flow, let's say, this side being the positive, that being the negative. The water will flow like this. The water will flow like this, but look at what happens when it gets there. It's a T-junction. You know, at a T-junction, Cars can go that side, and then cars can go that side. Even the water, same thing. Abanye bayangale, abanye bayangale. And then from there, they join and they continue like that. So can you guys see? That means this portion is in series. That portion is in series. That portion is in series. But the moment it comes to that T-junction, what the water does, abanye bayangale, abanye bayangale. Okay, so for example, if you had 20 liters of water flowing, if 10 liters goes that side, that means the other remainder will come this side, which is going to be 20 liters. Why? Because this total is the one that splits. Part of it that side, part of it this side. But if, let's say, 5 amperes being the current or water, if it goes through that side, that means this side we are going to have 15. Because when you add them together, they need to take you back to the total before they split. Or if maybe 19 liters come this side, then it means one will go that side. As we continue, I will explain how water splits and what influence water to split. Maybe while we're still on this one, I can still explain it, it's fine. So if we have too much of resistance on this side and little resistance on this side, then it means more water will go through where there is little resistance. It's like these things are too many soldiers, you see. So if too many soldiers are that side, that means more doses will come on this side where there is little resistance. That's it, honorable members. But if the soldiers that side are equal to the soldiers this side, then it means the doses will split equally. That's how it works. Too much resistance, less flow. Little resistance, more flow of current. Equal resistance on both sides, equal split. Did you guys understand me on that one? Laka nkulunkulu libandla elthembekile. Ningizwile no?
Yes, sir.
Yes,
Yes,
sir.
sir.
So,
Yes, sir.
Okay. Goodest. So now, let's say, we have 1 ohm on that electric circuit of mine. Let's say we have 1 ohm there, 2 ohms there. So that means in terms of the current, if the current flows, it flows like that. When it gets there, more current will flow through this side because there is little resistance, but very little resistance will flow through that side. Then it joins. So if the total was 3 amperes, if the total reading was 3 amperes, then as it splits, you might find that maybe, let's say, a 2,5 this side, and then maybe 0,5 this side. At the end of the day, when you add that and that, it has to take you back to that original. That's what you need to know. Okay, so now I want to calculate a R parallel. You see, I have that and I have that. So this is how parallel calculations work. You see these two, which are separate. When you use the parallel formula, it's like you're combining them. So you say 1 over R parallel in small letter. You write the formula R1, 1 over R2. Then you say 1 over R parallel equals 1 over your first resistor is 1, and then the other one is 2. Can you guys see what you've done? You wrote the formula, number 1, number 2, you substituted, number 3, you write the final answer. This is how you do the final answer. You just take exactly what you substituted with, but you'll say to the exponent -1. That's how you do it. So that means you have exactly that. You just punch it on your calculator. Trust me, it will give you an answer which is going to be a decimal. Let me quickly work it out there. And then you can just say 1/1. You must always punch it like this on your calculator. You must have a calculator that do these fraction patterns. If it doesn't, just know that osenkinge. Can you see what it gives you? 0,6 7 when we round it. So 0,67, but you must say ohms. So that means this is your R parallel. What does that R parallel mean? R parallel means what you've done, it was to combine these two into a single resistor. So it's like on that original circuit, this is what you are now having. It's like you serialized. You converted it from being parallel to now being a series having a combined resistance of 0,6 ohms. So it's like we took it from this to that. That's why I say it's like we serialized it. You mustn't say serialize. You mustn't mention this word in class. It's just a word that I came up with when I was studying these things on my own. To say, if I want to easily understand or know something, you just say you serialize. Ningzwile nonke bandla lakaNkulunkulu. Yebo nomqha.
Yes, sir.
Yes, sir.
Yes,
Bantu
sir.
bakithi.
Yes, sir.
Okay, then it's fine. It's fine. I've got something for you. I've got something for you. This is what I've got for you. Let us say for some reason we have that. We have that. And then I'll say that. Maybe let's say 2 ohms there, and I'll also say 2 ohms there. So now my question, I will say calculate R parallel. Maybe there I'll just say 20 volts. Yes. Quickly, can you do that calculation? As soon as you are done, comment in the comment section, and please do say I'm done. Guys, can you see the work that you need to do? Can you guys see the work that you need to do?
Yes, sir.
Can you guys see the work that I need you to do? Okay, I will give you 2 minutes to work it out. Okay, and let's see what you guys have done. Let us see what you guys have done. And okay, Lihumo has got an answer. Okay, let me wait for others to respond. Let's wait for others to respond. Let's wait for others to respond. Let me see if there's anyone. Okay, we've got more comments. Andrew got 20, and we've got 20. Okay. 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 Channel got 1 ohms. Okay. Maybe for the sake of time, let me do it. And let's see. So the formula to calculate R parallel, it's only one formula. There's no any other. Is this one which says 1 over R parallel equals 1 over R1 plus 1 over R2. Then you will say 1 over R parallel is equals to 1 over R1 is 2, that you plus it with the other resistor, which is 2. Nay. Then I said, you just say R parallel is equals to. You need to rewrite exactly this thing as it is. Nay. Then you just say to the exponent -1. Then you say this is equals to. You just punch that on your calculator. It will do everything for you. It's like a shortcut, honorable members. You will understand it at a later stage. So it's like you have 1 over 2 plus 1 over 2. Obviously, half plus half is 1. And then 1 to the exponent -1, it gives you 1. As you can see there, the answer is 1. So that's how you get your 1 ohm on that one. Did you guys understand what I have done on that one, honorable members or members who are honorable? Ningzwile nonke, Andrew, Atlil, Humo, Mangliso, Ompile, and Chanel. Did you guys see how quickly this can be worked out?
Yes, sir.
Yes, sir.
No questions. We are all okay on that one.
Yes, sir.
Okay. Then it's fine. What is it that I want to do? I think the other thing that I want to do, it is to just give you guys an example of something that you should expect generally in a test or exam. For example, you can have 2 ohms there, you can have 1 ohm there. Maybe we can have 2,5 ohm there, we can have 3 ohms there. And then maybe we can even have 20 volts there. It's fine. Sometimes they can just connect an ammeter there. So the first question, they can say a calculator R total. They like this question. Second question, they will say reading on the ammeter. Okay, so now I'm going to answer these questions. Because of space, let me start there and say number 1. What do they want you to calculate? R tot. We only have one formula to calculate R tot. Never confuse it. It's only one formula to calculate R tot. The one for R parallel is not for R tot, it's R parallel. So the formula to calculate R tot, it's only one, which says R tot is equals to R1 plus R2 plus R3 plus other resistors which may exist. So by the look of things, our R tot will be, I said I like starting from the left, so it will be 2 ohms that you plus it with. Can you see you've got these two connected in parallel? So just say R parallel, and you will still need to plus it with this one. Luckily, it's in series. Then you have 1 ohm there. So now you have a problem that you need to deal with that are parallel. So that means you need to now seriesize that parallel connection. What do I mean by seriesizing? It's like you have series there, you have series there. Let's try to seriesize this one. How do we seriesize it? We use this formula for seriesization. So you have 1 over R parallel. What did I say? You just substitute. You have 2,5 that you must plus it with 3. And then what did I say? I said now you say R parallel and equals, you rewrite it as it is, but you will say to that. Now we punch it on a calculator. Let's see. So we have 2,5, and then here we have 3. What is the answer? 1,6. No, 1,36. So that means our R parallel is 1,36. You must say ohms. If you don't say ohms, then it's wrong. So it's like now you have that series. Now this has been seriesized. Then you will take it and substitute it there to the formula for R tot. Then it means your R tot, it is therefore 2 that you plus it with 1,36 that you plus it with 1. That is 3, 4. Trust me, it will give you 4,36 ohms. That's how you calculate your R total. Look at this one. They say the reading on the ammeter. You will then need to use this formula because that's where you will get your I. What is V? We were given as 20 volts. I is what they want you to calculate. What is your R? You just calculated it now as 4,3 that. So that means your I will be equals to, you just divide by that 4, something, so that so you just say 20 divided by the answer and gives you 14,67. It is the reading on the ammeter. 14,67. Then you say amperes. Okay. Any questions, honorable members, or did you all understand? Can I give you guys something to work out and submit via inbox after the lesson? Can you guys see how nice these things are? Umpile. What do you want to do?
Sir?
Nadia ntsamaela ke tsore wena dia o tsamaelana.
E di tsamaela, sir.
Le nna dia ntse fela. Chianeo. Wa kushisha go women.
Hey, hey.
Ya o tsa Andrew, ya o tsamaela mogala. Atlile humo mangli so. O wa mo defo ka mo women.
I understand, sir.
You understand, ne? Okay. I want to see if indeed you guys understand. I will give you guys this. Question number 1, I want you guys to calculate taught. Question number 2, reading on A. Can you guys take a screenshot of this? Then you will need to do this question, and then you will submit by sending me a WhatsApp inbox. Are you guys done taking the screenshot? Guys, are you done taking the screenshot?
Yes, sir.
Yes, sir.
Good, goodest. So you'll need to very quickly work on that. And then let me know. No, you take a screenshot, work on it, submit. Yes, and then submit. Okay, guys.